Awesome. I've seen Brian present a few times, and I've always had a lot of sympathy for whoever comes on after him. And now I have to come on after him, so I feel like I deserve this. So my talk today, I'm going to try and sort of move out of the hypothetical and talk a little more about the practical realities that we're seeing as people try to move Dockers from a development tool or a tool that they're using at an individual or a small team level to kind of answer the question, how is this going to work as organizations start to adopt it? Because over the last 10 years or so, I spent a lot of time building clouds. My last company was called container.camp. We started a project called CloudStack, and we built hundreds of clouds for people like Apple and BT and Zynga and all sorts of companies. And one of the interesting things about cloud computing was that you always were building a very finite set of resources and then implementing a framework for how you were going to use those resources. So, each cloud was slightly different. Each set of services were really tailored to the organization that was consuming them, or if it was a public cloud, like in the case of somebody like a British Telecom, it would be tailored to their customer base. Each one would have different hypervisors, different network models, different storage models. And in the end, you ended up with effectively a world of islands, right? Every cloud, very different, very unique to the organization that's built it. And of course, interoperability falls apart. And in a lot of ways, running these clouds became just disastrously difficult because they were so tightly integrated with the underlying infrastructure. So about a year and a half ago, my co-founder and I decided from that company, we'd been acquired by Citrix back in 2011, and we decided to leave and start Rancher because we really felt after looking at sort of the progress of things like private cloud and the progress of public cloud that all of the promise of application management in the cloud, all the promise of hybrid cloud was really false promise. There really wasn't a lot of opportunity to build common frameworks that were going to be able to run across clouds. There wasn't a lot of opportunity to actually manage multiple clouds in a way that was in any way really useful for organizations that wanted to have things like portability or wanted to be able to design applications that would run anywhere. At least not until containers emerged, until containers became a common vehicle that we could use to solve some of the more underlying challenges of deploying applications. If we could deploy the same container and later, as we've moved into application management around containers, the same entire application environment from a single laptop to a single, to any cloud, any infrastructure, we've opened up a lot of opportunities to solve these problems that people, I think, expected cloud computing would resolve. And so in the last year, just talking to companies that had maybe built out big cloud infrastructure or had been big consumers of the public cloud, containers have become top of mind. And they've looked at containers as a dramatic improvement on the way they think of applications. And in a lot of ways, a change for what it means to, what does the cloud mean? The cloud has always been very differentiated. I mean, if you use Amazon or use Google, you don't get the same experience in any way. I mean, they're very different systems. If you use vCloud Air, and you're talking about a different hypervisor, a different image format often. So what is it? What is the real value of the container to the large organization? In a lot of ways, it's the first chance to standardize images and application formats and eventually infrastructure services, networking, storage, load balancing, service discovery across environments. So as large organizations, we've been talking to them about what they're going to do with containers, and I say large, it's very similar. In fact, I spent this week here in the UK just meeting with a lot of people that are part of our beta with Rancher and just talking to them about how they're using this open source technology. And it was interesting because the first people we met with, one of the first ones, it's kind of hard to see on the side, but it was an online and physical resource retailer. They've got maybe 50 stores around the UK, and it was interesting because they're like, well, look, the key for us with containers is we want to be able to manage the entire dev cycle of these different applications with different teams. We want to do it consistently. We need to kind of, the main role of this is to accelerate what we're doing. We want to have a lot more releases. We want to have effectively move to an architecture that allows us to consume microservices. And we're going to, inevitably we have different resource pools where we deploy these applications, from on-premise data centers that we actually run some applications into, we've just moved to Rackspace, and we're thinking about running some things as we move into Germany, which is sort of where their next growth market is, on a second cloud that's based in Germany. So different infrastructure, different teams, all moving towards containers. but not a huge team. I mean, they probably have 20 developers, I think, in the whole organization. So one size organization, but still facing problems of management, of collaboration, of, resource orchestration. Another group we met with yesterday was an enormous financial services company, probably one of the top 10 in the world. And their requirements they were talking about were, look, we have 100,000 servers. They range in, we run them in dozens and dozens of data centers. We, today take months to get people access to a single VM. Even with all the cloud projects we've implemented, it hasn't really gotten any better. Teams are clamoring for access to containers. We need to find a way as a large organization to standardize how we deploy containers, but at the same time, we've got teams that are talking about wanting to use Kubernetes. We have people talking about wanting to use Docker Compose and Swarm. We have other teams that are talking about other container formats, maybe. So we have a lot of complexity coming in requirements, and somehow as an IT organization, we want to deliver this as a service. We want to deliver a container service to our people. And as part of that, we're going to have to know what they're doing. We have to understand, how to manage the registry, how to manage the audit piece, how to actually understand what's running out there in our domain. So similar set of requirements in a lot of ways from a 40 store small retailer to an enormous global financial services company. Another health company we met with was talking about effectively the same thing. They're moving everything into Amazon, but they're, as they do that, they want to transition from effectively monolithic to microservices architecture. They want to implement containers to dramatically improve how they deploy the test environment. So they were trying to figure out how to do better test environments, accelerate their innovation, and containers seem like the right answer. But again, lots of people, lots of different approaches of how they want to manage each individual application. So consistently, we keep hearing people talk about when we ask them, well, what is this project? What is it that you're trying to do? And they'll call it a Docker project. They'll call it maybe something like a microservices project or a re-architecture project. But often it becomes the container service platform. Like they talk about, we want to build a container service. We want to build a container service for our organization. And the goals are pretty consistent. Like they talk about, one is we're expecting in the future to have a heterogeneous source of computing resources. We're going to have systems running in our labs. We're going to have bare metal systems. We're going to have VMs. We're going to have multiple cloud providers. And we want to have a consistent way of deploying to these different pieces of infrastructure that we have. Across that, then, we have different orchestration systems. Like we're hearing, I think Brian put it really well. There's a plethora of choices for how we want to manage these different applications. And, in the true DevOps spirit, I think a lot of the thinking is let teams decide. Let teams decide what tool works for them. As long as the system we implement allows us to maintain and support these different approaches, we'll see benefits depending on the application or the architecture. So different tools like Kubernetes or Swarm and Compose or Mesos will sort of emerge as ways that we define our applications. And we'll see, different application definition formats like Compose and Kubernetes and Tosca and other things sort of change over time. It's not going to be a consistent thing. And so organizations are trying to understand how to support different orchestration frameworks in a standard way while taking all of this and whatever they implement and plugging it into the tools that they've been building up from a DevOps perspective, like monitoring tools and logging tools and, to some extent configuration management tools, as well as their CI tools. And really, a lot of the way what it is about, it's about these different teams with very different DevOps pipelines being able to consume whatever resources make sense from an organizational perspective consistently. So you're bringing together all of these things if you want to implement a container service. And that's, in the end, what seems to be, in a lot of these organizations, the gap in terms of moving from Docker or containers as a development tool or a tool that's used by a small group or used in a single implementation, like used for a single application, to moving to containers as a corporate standard or a framework or a service that's delivered, whatever the actual implementation may be. And it's this idea of a container service, which I think in a lot of ways, Amazon may have coined this term when they announced their Elastic Container Service last year. But the idea of a consistent platform to run containers, which I think we're going to see over the next year, really drive a lot of the thinking about how containers have become adopted. And so, what does this mean? What is a container service? It's fundamentally, it can be public, it can be private, it can have, I think there's going to be lots of different implementations of container services. And what a container service looks like for different size organizations is probably going to depend on their specific requirements. How many applications are they running? I doubt at at a large web scale organization where they're running maybe a relatively small number of services, but at enormous scale, they're going to make the same choice as they will at a high street retailer or at a bank where they have maybe tens of thousands of discrete medium-sized applications which have unique, different requirements. So different requirements, multiple users, multiple teams are able to come in and effectively get consistent experience across different platforms. So as they roll and deploy their applications and their containers, while the framework may be different and the underlying VMs and the underlying storage and the underlying bare metal resource, whatever it is they're deploying upon may be different, as an organization, you want to standardize how things like container networking work, container orchestration work, container storage work. So some of these consistent things, I think in a lot of cases, you don't want to be re-implementing over and over and over again because they're the real bottleneck. The security, the deployment patterns, this is what slows down adoption of things like containers. I mean, I think if in a lot of organizations you talk to where containers have been in sort of what I'd call like an eval mode, they've been in an eval mode for maybe 6 to 12 months as people get comfortable with the idea of using them, but also as they test out this wealth of cool open source tools that are coming to solve different components of the stack. And so in a lot of ways, as organizations adopt containers, they're going to be adopting them with an assumption that, okay, we're going to deploy this using this standard approach to container networking or service discovery or container load balancing or some of the sort of problems that we see when we try to deploy containers. And then these platforms need to integrate with the DevOps tools and incorporate some type of orchestration frameworks, because that really is when you start to consume, Docker Compose templates, that all sorts of things happen. So the private container services that we're seeing people implement tend to look kind of like this. They'll build it out, they'll deploy a container service, but it starts by connecting into the corporate user directory so that teams and individuals are able to deploy environments. And environments are really the kind of first step to understanding, how to do multi-tenancy with containers, because you're going to want to find scopes of communication, scopes of resources where you want to deploy your application. So every environment gets provisioned with some type of resources, and these resources could be bare metal, they could come from the cloud, they could be VMs. The cool thing about fundamentally with containers is that it really shouldn't matter. As long as it's a Linux host or a host that can run Linux and enable, running a reasonably good, reasonably current version of Docker, should have a lot of consistency in how you deploy. And then in this environment, it may be scoped and sized based on the requirements of the application or the team or the group, because an environment is going to be an area where you define the network, for instance. The container network should sit within an environment. The container service discovery should sit within an environment, so that when you plug this into your registry, you're able to deploy individual containers, groups of containers, clusters, and even entire application frameworks easily from something like Compose or from Kubernetes or whatever it is that you decide to use as the framework to describe your applications, your relationships between the different services that make up your application. So this concept of a container service really starts to become a portable implementation of a hybrid computing environment, because these environments can run anywhere. Because I can deploy consistently my Compose environment everywhere from my laptop to Amazon to Google to bare metal servers that make up my data center, that's where it becomes really compelling. And where those resources come from really shouldn't matter. There's certainly advantages to running containers on bare metal, but realistically, a lot of the capacity that we have access to, especially as groups, is virtual machines coming from VMware or coming from a cloud provider. And so as we take these hosts, what's happening is within this framework, within an environment, there's a number of services that have to be delivered under the covers in order to make the application really work. They include, probably most importantly, the network that connects these containers. As the containers come online, you have to be able to establish an SDN, you have to give them IP addresses, you have to be able to do things like service discovery and DNS, because containers are so ephemeral. They come and go, they scale up, they scale down, they're often replaced with a new version. You want to be able to describe services, describe service relationships, and enable those things to exist continuously, despite the fact that containers themselves may come and go quite quickly. And so networking, service discovery, and load balancing all become critical in terms of actually taking an application, turning it into a containerized application, and rolling it out to users. Similarly, if you've played with Kubernetes or you've gotten familiar with Docker Compose, concepts like health checks and maintaining the availability of a service it really needs to be a core capability of the systems. You need to be able to use the fact that these applications are distributed within, maybe across multiple hosts running in the same cloud, or across even different hosts running in different clouds. You need to be able to use the fact that you've got lots of nodes talking to each other to find what's going wrong. Like, when has a system gone down? When is my system not available? When is a container down? Do HA, bring things up. So all of these services, all the way down to storage, persistent storage, backup, HA, should all be part of the container platform, container management system, so that when you roll it out to users, they're really focused at the next level up. Whether they're just using the Docker CLI and saying, Docker run, individual containers or individual services, or they're bringing up Compose environments or Kubernetes environments, they can deploy these applications with the expectation that networking and storage and load balancing, all these capabilities will always be there regardless of where things run. And this is sort of the next step, in my opinion, of where cloud computing sort of falls down. Cloud computing tends to not work as you cross boundaries, because every one of these implementations, if you move from any, whether it's private or public cloud, they're always so different. How a system does load balancing, how it does networking, how it does images, how it does provisioning is consistently different. And so, if you just look at simple processes like testing software, it becomes, innumerably easier when you start moving to these containerized environments running, on, a consistent container infrastructure stack. So, you think about like just the test environment, where you create your test environments, upload a Compose script that describes the application you want to run into GitHub, your test environments. All of this from a Docker Compose file will be instantly deployed, identically to how you may have run it on your laptop in the cloud of your choice, or the infrastructure that you decide to run on. So in this case, just running a multi-tier, a Tomcat Java app that gets spawned out of a Compose file that's going to change as I do my releases. So often what we're seeing is that it's really the front-end work, the CI work that's happened maybe over the last 2 or 3 years, that's going to drive these systems. The Jenkins or the Bamboo that's calling out to the APIs of the container service, telling it, deploy this new version of my test environment, spin it up with the latest builds that we've just finished, deploy it at some scale, and then run a test container against it to validate, and then call a webhook that's going to go back to Jenkins and tell it, how the test succeeded or failed. This is what tends to happen within these environments, and they come and go very quickly. I mean, one of the people we were talking to just this week was talking about using, even with a relatively small team, they would have on a single application, a dozen test environments trying different things, spinning up resources, shutting them down when they don't need it. So I think the elasticity of the cloud combined with the consistency of Docker and containers really enables us to try things and deploy things in an automated way that just hasn't been possible before. So when you get into production, this really looks even more impressive, because you are deploying maybe your same Compose template or Kubernetes environment, and you're deploying it against infrastructure that's effectively tagged and designed specifically for the use cases you have. So if you've got high memory modules that you want to deploy against, or high SSD-based instances you want to run your databases on, you're effectively tagging infrastructure, tagging containers, and marrying them up when you deploy, so that you can schedule the right resources for the right components within your application. And once an application gets deployed as a Compose environment, it really becomes something that you can scale, that you can do health checks and monitoring on, that you can detect when issues occur and recover from automatically. Something you can upgrade very easily in place with rolling upgrades or blue-green upgrades, and start to see the kind of operational efficiency that's pretty common maybe in large web organizations, kind of pushed down to everybody. This technology becomes incredibly easy as you just use code-defined applications, based on things like Compose. And so as people, in larger organizations deploy these platforms, what they're really getting to is ephemeral, resources that are being deployed in a very consistent and prescribed way. So that, within this environment, I'm just changing my load balancer, pointing it to a new set of services, bringing those online, and, if necessary, rolling back when something goes wrong, because I'm just moving from one state of containers to a second state of containers. And that may go all the way down to the database, but it's effectively a consistent, persistent environment. So, what as this stuff emerges, I think you're going to see a lot of additional things that will differentiate organizations and how they think about containers for their users. Things like access control. How do I control who can actually, what people can do, what they're allowed to do on different implementations of my environments, RBAC. Already you're seeing a lot of demand with containers for better secret management. I think there's some really cool stuff that HashiCorp is doing right now with Vault that will probably permeate all of the work around containers within a year, because we're describing we're templating environments, but the reality is when we deploy one of these compose scripts, it's going to be different from dev to test. It's going to potentially run on different infrastructure. It'll have different configuration values across different containers. So secret management, performance management, often, one of the things we hear from people as they move into containers is, we can run the same application on lots of different infrastructure. How does it perform differently? How do I set at the application level requirements that the infrastructure needs to live up to? So all of this, all the way down to what I would call sort of the emergence of the service catalog, the emergence of the container catalog that goes beyond sort of an individual registry of containers, but more to entire application capabilities being offered as Docker Compose or Kubernetes files to be deployed on the fly. So teams will just say, I need a Couchbase environment, or I need an Elk environment, I need to deploy them, and pull from catalogs that are designed for your organization, so that when you script into say this is what an Elk stack looks like for our company, and this is what we want to use in terms of our Logstash implementation. I either take it as a service because the service has been running somewhere in our domain, or I deploy my own instance of the service, but with maybe some slight configuration changes, but I'm consuming things over and over again within within my organization, instead of repeat deployment and building that is so much the way things work now. So, the container service at the heart of all this is going to, from what we're seeing now, it's going to become, I think, a very standard part of an organization's infrastructure stack. And because of that, we've been working on this at Rancher for some time now, for about a year, but I think there's going to be a lot of options here. I think you're going to find that you'll be able to take things like container services as a service. I think there's already companies, Cloud66 is upstairs talking about it. They have a really nice platform that you can it's a SaaS platform that you can go into and consume, and it's really, it's very similar to this. It's a SaaS-based container service. And obviously, cloud providers like Amazon and Google are running their own cloud services that will maybe not offer the same type of portability, but they'll offer a lot of deep integration into services that are unique to that cloud. So you're going to see that this layer of the container service, I think, becomes really how containers get adopted quickly, how we sort of reduce the complexity and the challenge of, right now containers present to a lot of organizations. They take a while to get going. That's going to go away very quickly. So that was all I wanted to talk about, was just that transition. And hopefully it gives you an idea of where we might be 6 months or a year from now, and what your expectation should be as an organization, that if you want to start adopting containers, what are the requirements going to be? Maybe, do you want to run on different infrastructure? Are you comfortable, keeping everything in one platform? Do you want to run your own platform, or do you want to take it as a service? Do you want to run one stack of software from top to bottom from one provider, or do you want to, maybe have some groups use Docker frameworks and other groups use Kubernetes or Mesos or different things? So lots of different requirements that you might consider as you think about what type of container service you want to offer. But I think it'll be, regardless, it's going to be something that gets dramatically easier, as time goes on. So hopefully that tells you a little bit about this. We're upstairs and we have a little table, so you're welcome to come by and we can jump in. Happy to demo sort of some examples of what these container services look like. I'm sure a lot of you have tried Rancher and seen it at this point, but it's definitely, one of these areas that I think the barrier to entry is going to come down exceptionally fast. So I'm really excited to see what's happening in the space. Thank you.